So now we're ready to take derivatives of trig functions. So if you use the limit definition, that is f prime of x is the limit as h goes to 0, f of x plus h minus f of x all over h. So if you use that limit definition with your function f is sine of x, then the limit that you'll get out of here is cosine x. So cosine x is the derivative of sine x. And then if you use cosine x as your function, its derivative is negative sine x. So these are almost derivatives of each other. So the derivative of the cofunction has the negative sign. So now notice, since our trig functions have derivatives, they're differentiable. That means that they also have to be continuous. So differentiability is a stronger condition than continuity. If you have a slope of a tangent, then you have to have a continuous graph. Now, some other derivatives that we can actually show from these two, derivative of tangent x is secant squared, and derivative of secant x is secant tangent. And then derivative of cotangent is negative cosecant squared, and derivative cosecant is negative cosecant cotangent. So notice that all of the cofunctions, their derivatives here, all involve the negative sign. So let's try this out. We want to find derivative x cubed plus 1 times sine x. So this is a product of two functions. So let's let f be x cubed plus 1 and g be sine x. Then we want to do f prime g plus f g prime. So we can go ahead and figure our f prime and g prime down here. So our f is x cubed plus 1. So f prime is going to be 3x squared. And then derivative 1 is 0. And then our g prime, g is sine x, derivative sine x, cosine x. So now we'll go ahead and plug in. So our f prime, 3x squared, times g, which is sine x, plus f, which is x cubed plus 1, times our g prime, which is cosine x. And you could multiply this out, but we'll just leave it like that. That's simplified enough.